Hello students, welcome back to today's class on integers, and today we're going to discuss about word problems. Word problems are very important because the algebraic expression or the integral expression with integers will not be mentioned. We need to understand the question, the word problem, and then we need to frame it. And if you do any small mistake in that, your answer completely will be wrong, right? Before going to word problems, in the last class we have just started what is a distributive property, but we couldn't discuss. So we'll discuss about distributive property and then we'll go for word problems, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session with distributive property. So what is that property all about? You can see here, distribute, the name itself says that we are distributing something to remaining people or to remaining numbers. You're distributing, you can see carefully here. What are we distributing here? What are we distributing? For example, B plus C is there, okay, and A is there. Three numbers are there. We are distributing A to both the numbers B and C with multiplication. It is not addition, it's not A plus, it is A into, that is again a big mistake you do. You always confuse with A plus B plus C and A into B plus C. Okay, A into B plus C, these two are two different things. You should not confuse between these two, okay. It is B plus C. In the first case, we are just adding all the three numbers. Associative property we discussed. But now, you are having multiplication as well as addition, two different operations in the same property. Two different operations, one with the multiplication, one with addition. And we need to distribute whatever we are multiplying. We should distribute to remaining all numbers. You can see here, A we are distributing to B, so A into B, plus A we are distributing to C, so A into C. You should be very careful here. You should be very careful here. You have a positive between, okay, in between them. Don't try to multiply again these two numbers. What are we doing? A cross B, A into B, that is one term. Then this plus will come and then A into C. The same way here, if you carefully observe, this is one unit, C is another unit. So you need to distribute C to both of them. So you are distributing C to A, that is A into C or C into A, both are same. And C to B or B into C, both are same. We are distributing only the term which is being multiplied, not the thing which is added. You should be very careful in that. A into, when you are having into, that A should be multiplied, or to multiply for both the numbers, distributed for both the numbers. A plus B into C, that into C should be multiplied to both the numbers A and B. When you have the terms in bracket, it says that they are one unit. Whatever changes you want to do, you should do to the entire number inside the bracket, to all the numbers inside the bracket, correct? Let me give you small examples, okay? If you have 2 into 3 plus 5, okay, so that will be equal to 2 into 3 plus 2 into 3 plus 2 into 5. 2 into 3 plus 2 into 5. Don't again use addition or plus symbol in between them. It is the multiplication. So 3 2s are 6 plus 5 2s are 10. So that will give you 16. This is a 2 into 5 plus 3 is 8. 8 2s are 16. So 16 and 16, these two will be equal. 16 and 16, these two will be equal. Understand? Okay, so A into B cross C and A cross B plus A cross C, whichever number you are multiplying should be distributed to all the remaining numbers. Let me take one more example. 2 into 5 plus 6, so that is equal to 2 into 5, 2 into 5 plus 2 into 6 plus 2 into 6. So what is 2 into 5? 2 into 5 is 10 plus 2 into 6 is 12. So that becomes 22. 5 plus 6 is 11. 2 into 11 is also 22, right? The same way, we can also go for the next one. What is that? 25 into 3 and 25 into minus 3. It is again the reverse way. 25 we are distributing to 3 as well as 25 we are distributing to minus 3. So using distributive property, I can write that as 25 multiplied by both the numbers 3 plus minus 3 plus minus 3. So what is 3 minus 3? 3 minus is 0, so 25 into 0. 25 into 0, so that will give you the answer as 0. 25 into 3 is 75, 25 into minus 3 is minus 75. So these two will make the sum equal to 0. These two will make the sum is equal to 0. Understand? So this is about distributive property. You have one more question. You can try to do that. Find the product using suitable properties. 26 into minus 48 and minus 48 into minus 36. You can see here minus 48 is common in both the cases. So you can try to apply from there. Here also 625 is common with a negative and positive. So please take care of that. Okay. So from there you can try to find the answer. Please try to do this. Now let's move for the most important thing in integers are the word problems. We have discussed a lot of properties till now. Lot of applications, lot of operations, how to add, multiply and subtract, divide integers. So with all this information, let us try to have some questions on word problems. So what is the first question we are having? An elevator descends into a mine shaft at the rate of 6 meters per minute. Descends, what do you mean by that? Descends means going down. It's going down, okay. An elevator descends into a mine shaft. Mine means, okay, there is a mine area where you are mining, where you are doing mining. Okay, so it's moving down at the rate of 6 meters per minute. Per every meter, it is moving at a rate of 6 meters. If the descent starts from 10 meters above the ground, okay. So this is the ground here we were having. So above the ground, we are starting from 10 meters. From this point, the elevator is moving down. The elevator is moving down, okay. How long it will take to reach minus 350 meters? Minus 350. So you need to understand what is this negative. Sir, how can we have the distance as negative? See, the meaning of negative is always states that it is in the opposite direction. It is in the reverse direction. Positives are here, negatives are here, correct? In the same way, if you're saying positive is up, negative numbers are the bottom. Okay, so 10, and now it should move to minus 350 meters, at the bottom. So it should travel all this distance from this point to this point. So now tell me, what is the total length it is moving? What is the total distance it is covering? The total distance is equal to 10 meters above, and although it is a minus 350, it is stating that negative means reverse direction. The distance is 350 meters only. The distance is 350 meters. It is a plus 350 meters. The distance is always positive. So plus 350. So distance is equal to 10 plus 350. That will give you 360. Distance equal to 10 plus 350, that will give you 360. So now, the total distance that is being traveled by the elevator is total equal to 360 meters. But we should find how long it will take, means how many minutes or how many hours, what is the total duration of that journey at the rate of 6 meters per minute. Per 1 meter, if they are traveling 6 meters for 1 minute, for 1 minute, let me erase that and write minute. For 1 minute, let us say we are going at 6 meters. Then for 360 meters, how much time we are taking? Let me take this duration as x. So how to calculate this one? You need to cross multiply. 1 into 360, okay, 1 into 360, which is 360, is equal to x into 16, So how can you find x here? So the value of x will be 360 divided by 60, so which will be 36 by 6, which is a 60, right? Sorry, once again, 360 is equal to x into 6, not 60, it is 6. Right. So 360 by 6, so you know that 6 ones and 6 are 36, so you will get total 60. What are the durations? What are the units? Okay, is it 60 seconds or 60 hours? You know that 6 meters per minute. The units are very important. When you say 60, when you're not mentioning the units, you don't know whether it is 60 seconds, 60 minutes, 60 hours, 60 days, 60 years. We don't have anything. We cannot say that. So always you should be very confident with the units. So it is minutes, okay. So 60 minutes it will take to travel till minus 215, which is equal to 1 hour. Okay, 60 minutes or 1 hour, both are same. That is the total time it's taking to travel all this distance. Right? Let's move for the next question. What is that? The temperature at 12 noon was 10 degrees above zero. Above means positive. Above, upwards, okay, to the right, always it states that it is positive. 10 degrees above zero, 12 noon. What do you mean by 12 noon? It is 12 p.m., not 12 a.m. in the night. Noon, afternoon. Noon means afternoon, okay. Noon means 12 p.m. If it is decreasing, so at 12 noon, at 12 p.m., we have the degrees as plus 10 degrees. If it decreases at the rate of 2 degrees Celsius per hour until midnight, so it is decreasing at 2 degrees, okay. At every 1 hour, at 1 p.m., you will be having 8 degrees, correct? At 2 p.m., you will be having 6 degrees, so it is keeping on increasing. The point is, at what time would the temperature be 8 degrees below zero? Careful. It is not 8 degrees, it is 8 degrees below zero. That means at what time you will be having minus 8 degrees? At what time you are having minus 8 degrees? What would be the temperature at midnight? Midnight means middle of the night at 12 a.m. Midnight means at 12 a.m. Okay, we'll come back to this one. That is the second question. We'll come back to that. Let us try to understand about the first question. Starting at 12 p.m., it is at 10 degrees. From 10 to minus 8, what is the duration? What is the difference? Okay, so the difference in temperature is equal to 10 minus of minus 8. Difference of 5 and 3, 5 minus 3. 10 and 5, 10 minus 5. 10 and minus 8, 10 minus 8. Don't forget that extra negative. So that is 18. So total it should reduce 18 degrees. It should reduce 18 degrees. But how many degrees per hour it is being changed? 2 degrees, right? If it is decreases at the rate of 2 degrees per hour. So per 1 hour, if you have a change of 2 degrees Celsius, so how much time you need to have for 18 degrees Celsius? How much time you need to have till 18 degrees? It's very simple. 2 9s are 18. So 1 into 9, 9 hours. If you're confused, just take it as x and cross multiply. So 1 into 18 is equal to 2 into x. From here we'll get x is equal to 18 by 2, which is 9 degrees. 18 by 2, sorry, it's 9 hours. It takes 9 hours to reach to the point minus 8. So, starting from 12 p.m., if you go for 9 hours, where do you stand? From 12 p.m. to 1 p.m., 1 hour. To 2 p.m., 2 hours. To 3 p.m., 3 hours. So, that way, to 9 p.m., this is a total of 9 hours. From 12 p.m. to 9 p.m., it is a total of 9 hours. By that 9 hours, it will be decreasing by 18 degrees in total. But the initial point is plus 10, so it will reach to the final at minus 8 degrees. Minus 8 degrees, correct? So, at 9 p.m., the temperature will be minus 8. There is one more part of the question if you understand. What would be the temperature at midnight? Midnight means at 12 a.m. Midnight means at 12 a.m. Let me see that right once again. Right. Okay. So let me tell one thing here. At 9 p.m. you're having minus 8. So 10 p.m., 11 p.m. and 12 a.m. 9 p.m., 10 p.m., 11 p.m. and 12 a.m. So it is minus 8. Now 2 degrees less, you will fall at minus 10. 2 degrees, minus 12. 2 degrees more, minus 14. So at midnight, the temperature will be at minus 14 degrees Celsius. Right? From 10 to minus 8, you're having total 18 degrees Celsius as the difference in temperature. For every 1 hour, you have 2 degrees Celsius down. So total For 18 degrees, you need 9 hours of time. Starting from 12 p.m. to 9 p.m., you're having 9 hours, right? So, you'll be falling at 9 p.m. minus 8, and at the midnight at 12 a.m., you'll be having minus 14 degrees Celsius. Understand? Right? Easy question. So, let's move for one more question. A certain freezing point, okay, once again go back. A certain freezing process requires the room temperature be lowered from 40 degrees at the rate of 5 degrees Celsius every hour. Okay, so there is some procedure, okay, there is some process going on, freezing process. So what is the condition there? The initial temperature is 40 degrees, from there it is being reduced at the rate of 5 degrees every hour. Okay, so the room temperature will be lowered means reducing. From 40 degrees, we are reducing at the rate of 5 degrees every hour. What will be the room temperature 10 hours after the process begins? 10 hours after the process begins. So, I'll tell you like this. So, 40 degrees Celsius is there. 40 degrees Celsius is there. It is decreasing at the rate of 5 degrees every hour till 10 hours. Okay. 5 for 1 hour, it is reducing at 5 degrees. It is reducing at 5 degrees. Okay. So for 10 hours, it will reduce by 5 into 10, 50 degrees. It will reduce by 50 degrees, correct? It is reducing. From the initial point, it has reduced 50 degrees Celsius. What is the initial point? 40 degrees. So from 40, if you are decreasing minus 50, okay, you should not go up because you are not increasing, you are lowered. Lowered means you are decreasing. That is the reason I am saying word problems are very important to understand and very easy to solve once you understand the question. Okay, so 40 minus 50 will give you minus 10 degrees Celsius. Minus 10 degrees Celsius, right? What will be the room temperature 10 hours after the process begin? So it will reach till minus 10 degrees. It has started at 40. From 40, after every 1 hour, if it is reducing 5 degrees, next it will go to 35, next 30, next 25, then next 20, and so on. After 10 hours, you will be at a state of minus 10 degrees Celsius. You will be at a state of minus 10 degrees Celsius, right? Easy question. Let's move for one more question. What is the next question we are having? In a class test containing 15 questions. Okay, you're writing an exam. The total questions you're having are 15 questions. The point here is 4 marks are given for every correct answer. 4 marks are given for every correct answer and minus 2 marks are given for every wrong answer, incorrect answer. It's not that you will get 0 marks for wrong answer. Here you are having negative marking. Negative marking means if you write wrong, you will lose marks. Okay. So, plus 4 and minus 2, that is the evaluation. If you are getting correct answer, plus 4. If you are getting wrong answer, minus 2. What's the first question? Bharati attempts all the questions. All means 15 questions. Okay. But only 9 answers are correct. 9 are correct. So 9 into 4, she will get 36 marks. But is this her final score? Had there been no negative mark for incorrect answer, that is her final answer, final marks. But as she is attempting all the questions, out of 9, you still have 6 questions unanswered. 15 minus 9. Out of 15, 9 are correct. So 6 are wrong. For every wrong answer, you are having a minus 2 marks. So 6 into minus 2 will give you minus 12 marks. So now your final score will be the addition of these two. Your final score will be addition of these two, 36 and minus 12. 36 and minus 12, you will be having 24. See, 24 marks is her final score. Although she got plus 36, but due to the wrong answers, due to the incorrect answer, she has fallen to 24 marks, right? So once again, I'm saying, whenever in whichever exam you're having a negative marking, please don't attempt the wrong answer which you're not sure. Only attempt the answers which you are 100% sure, and that 100% sure means it should be correct. Only attempt. For example, there are 15 questions, and if, let us say you only know one question, just write one and come out. Don't try to attempt all which you don't know. Right. So let me discuss one more question, then we'll stop it here. So in the same case, okay, one of her friends, Hema, attempts only 5 questions. Only 5 questions. Only 5. So 5 into 4, how many marks? 5 into 4 is 20 marks, and all are correct. It was given all are correct. What will be her total score? It is 20. See, in the previous case, what happened? Although the person got 36 with minus 12, she landed at 24. Writing all the questions, getting 24, and writing only 5 questions and writing 20 marks. So which is best? I can say writing 5 questions and getting 20 marks is good than getting all your score is high, okay, but not always. When you're trying to attempt every question, when you're having negative in the competitive examinations, it will be very difficult task to keep up your score, because you'll be falling with the more and more negative marks, right? So please be very careful. So one more question which I'm not going to do it now. I'm leaving this question for you, but just try to understand what is this question about. A merchant on selling rice earns a profit of rupees 10 per bag. Okay, he is earning rupees 10 per bag of basmati rice sold, and a loss of rupees 5 per bag of non-basmati rice. See, there is a rice called basmati, which you generally use for biryanis, right? When you see the biryani, you have a different kind of rice, a bit lengthy than the normal rice, okay, with a different fragrance, right? So a merchant is selling both basmati and non-basmati. How many bags? We still don't know that, okay? So for a basmati bag, he is getting 10 per basmati, so plus 10 is a profit. For a basmati bag, he is getting plus 10. And loss of rupees 5 per bag for a non-basmati. For non-basmati rice, loss of 5 means loss is again in the reverse direction of profit, so we keep a negative 5, right? So the point here is he sells 3,000 bags of basmati rice. So this one he is selling for 3,000 bags at a profit of 10 rupees per bag, and 5,000 bags of non-basmati rice in a month. 3,000 basmati and 5,000 non-basmati bags. So what is the profit or loss in a month? So I'm not going to do this one. You have every information given. Just multiply 10 into 3,000 and minus 5 into 5,000. Add these two. If you are getting a positive answer, that means you are getting a profit. If you are getting negative answer, that means that you are getting loss. Profit is always with a positive, and loss is always with a negative. So when you are getting negative answer here, you will be losing. You will get a loss, right? So one more question here. What is the number of basmati rice bags he must sell? Okay, so now we need to find the number of basmati bags. Okay, has to sell to have neither profit nor loss if the number of bags of non-basmati rice is 6,400. Non-basmati rice, you're having 6,400 bags into, for every bag you're getting a loss of minus 5 rupees, right? So you know how much is this amount. But to balance this one with neither profit nor loss, you'd have X number of basmati bags with plus 10 as a profit. Given. So these two should be equal. In terms of numbers. That means you should not have any positive or any negative. Then you can say that you are having 0 rupees profit or 0 rupees loss. You're not having a neither in a state of profit nor in a state of loss, right? A beautiful application, so please try to do it yourself, right? So that's all with all the word problems here, and that's all with the chapter of integers. In the coming lecture, we are going to discuss about the next video, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we will be discussing about uniform and non-uniform motion. And after that, we'll go into a few practice questions also. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. Right, so whenever we discuss about uniform motion, remember, particularly in physics, when we say uniform we mean what? It means it is constant. Okay, so when we say uniform motion, it is like constant motion. So a motion with constant speed is called as uniform motion. Now there is another proper definition for that. I'll also go into it. But remember this, uniform will mean constant. So uniform motion will mean a motion with constant speed. Is that clear? Good. So here, speed, look at the second point. Speed of the object remains constant in uniform motion. Okay, good enough. Then do we have anything else? Yes, we have a proper definition. I'll go into that. For that, let's go into this example. So here, look at this. At 4 p.m. a car is here. At 5 p.m. the same car is here, and at 6 p.m. the same car is here. So you look at this, from 4 p.m. to 5 p.m. From 4 p.m. to 5 p.m. how much time is there? 1 hour, yes or no? Exactly after 1 hour, from 4 p.m. you will have 5 p.m. The time interval between them, the time taken between 4 p.m. and 5 p.m. is 1 hour. And what is the distance travelled between 4 p.m. and 5 p.m.? That is 30 kilometers. So distance is 30 kilometers and the time interval is 1 hour. Similarly, if I look at this case, 5 p.m. to 6 p.m. the time interval is 1 hour. And the distance travelled is 30 kilometers. The time interval is 1 hour and the distance travelled is how much? 30 kilometers. Clear? Seen that? Good. Now, keeping this in mind, look at the definition. Do you have equal time intervals, 1 hour and 1 hour? So time interval is equal. And is the distance travelled equal? Yes, 30 kilometers, 30 kilometers. So look at the definition now. If a body covers equal distances, 30 kilometer, 30 kilometer, equal distances in equal intervals of time. So 30 kilometer in 1 hour and again the same 30 kilometer in 1 hour. Equal distances in equal intervals of time, it is said to be in uniform motion. Constant motion. And if you calculate the speed in both the cases, let us calculate the speed also. Here what is speed equal to? Speed is distance by time. So it is 30 kilometers upon 1 hour, which is 30 kilometer per hour. From 4 p.m. to 5 p.m. The same thing if I again calculate speed for 5 p.m. to 6 p.m. Distance is 30 kilometers. Time is 1 hour. That means again 30 kilometer per hour. So here also speed is 30 kilometer per hour. Here also speed is 30 kilometer per hour. That means you can clearly say that speed is constant. So uniform will mean constant. So uniform motion will mean a motion with constant speed. The proper definition is what? Equal distances in equal intervals of time. If a body covers equal distances, 30 kilometer, in equal intervals of time, 1 hour, it means it is said to be in uniform motion. Clear? Good. So here the keywords are important. Equal distances in equal intervals of time. Those are the keywords which define uniform motion. We'll go into other examples and that will make things much more clear for us. Okay? Okay. Look at this. Find whether the given motion is uniform or not. Now let's do that. Let us first find out the time interval. Look at this, time in seconds. It is 0 to 10. So time interval is 10 minus 0. 10 seconds. Then you have 10 to 20. It is 20 minus 10. 20 seconds. Then you have 20 to 30. 30 minus 20. Sorry. here it should be 10 seconds, right? Okay. Then 30 minus 20. How much again? 10 seconds. Then 30 to 40, which means 40 minus 30. How much again? 10 seconds. So time interval 10 seconds, 10 seconds, 10 seconds, 10 seconds. Time interval is equal. Now let's see, for equal time intervals, if the distance traveled is equal, then it is uniform motion. So here, for the first case, 0 to 150, that means the distance traveled is 150 minus 0, 150 meters. Then here, 150 to 300, so it is 300 minus 150. How much is that? 300 minus 150. 0, 0. Then 10 minus 5. Then 2 minus 1, 150. So again it is 150 meters. Then you can again go for 300 to 450. It is 450 minus 300. How much is that? 450, 300. Subtraction 0, 0 minus 0, 0, 5 minus 0, 5, 4 minus 3, 1. Again it is 150 meters. Then again 450 to 600, this 600 minus 450. How much is 600 minus 450? Everyone do the calculation. 600 minus 450. That will again be 150 meters. So you can see 10 seconds, 10 seconds, 10 seconds, 10 seconds. Equal time intervals. Distance traveled is 150, 150, 150, 150 meters. So equal time intervals, equal distance traveled. So what can we say that? We can say that it is uniform motion. Equal distance traveled in equal time intervals. That is, here we had 150 meters, distance traveled was 150 meters in how much time? 10 seconds. 10 seconds, distance traveled is 150 meters. So what will speed be equal to? Speed will be equal to distance by time. Speed will be equal to distance by time. That means it is 150 meter by 10 seconds. So 0, 0 you can cancel them. What is remaining? 15. The speed will be 15 meter per second and the speed is constant. Constant speed. Obviously, we need not calculate speed according to the question, but we are doing it. So, find whether given motion is uniform or not. Yes, it is uniform. Yes, it is uniform. Clear? Understood? Simple enough? Good. So, then you have non-uniform motion. I told you uniform means constant. So non-uniform will mean not constant. So you have a simple example here. Look at the example. 4 p.m. to 5 p.m. time taken is 1 hour. 5 p.m. to 6 p.m. time taken is 1 hour. But look at distance traveled. For the first 1 hour it is 20 kilometers. For the second 1 hour it is 40 kilometers. So time interval is equal. But the distance traveled is unequal. So unequal distances in equal intervals of time. So that means it is non-uniform motion. And if you look at the speed, here speed is 20 kilometer upon 1 hour, 20 kilometer per hour. Here it is 40 kilometer upon 1 hour, 40 kilometer per hour. Obviously here speed is 20 kilometer per hour, here speed is 40 kilometer per hour. The speed is clearly different. Here and here the speed is clearly different. Understood? That's what we are talking about. And speed does not remain constant in non-uniform motion. Good? That's good. Okay. Oh, okay. So let's again go into another example. Here, find whether given motion is uniform or not. Another same example, time in seconds, 0 to 10, 10 minus 0, 10 seconds, 10 to 20, 20 minus 10, again 10 seconds, 20 to 30, 30 minus 20, again 10 seconds, 30 to 40, 40 minus 30, again 10 seconds. So the distance traveled is equal, pretty clear. The time taken is equal. Now let us look at the distance traveled. 0 to 50. That means 50 minus 0. So for the first 10 seconds, the distance traveled is 50 meters. Then if I look at the other interval, it is 90 minus 50. How much is 90 minus 50, everyone? How much is 90 minus 50? Yes, that is 40 meters. So you can just look at this. 10 seconds and 10 seconds equal time intervals, but the distance traveled is not equal. 50 meters, 40 meters. Distance traveled is not equal. So that means it is a non-uniform motion. Simple. You can even verify others, but it is actually proved. If I go for 180 minus 90, it is 90 meters. Then 180 to 230, 230 minus 180, 50 meters. And clearly see the distance, the time interval is equal, but the distance traveled is not equal. That means it is the case of non-uniform motion. Clear? Good. Let's continue. Now identify whether the following are in uniform motion or not. Some practical examples, by the way. Movement of hands of a clock. You can take any hand, you can take a second hand, you can take a minute hand, you can take an hour hand. What do you think? Is it uniform or not? Movement of hands of a clock. Uniform or non-uniform? What do you think, everyone? Yeah? And the answer is, it is uniform. Now, why is it uniform? I'll explain. Look at this. The minute hand is moving. The hour hand is also moving. But yeah, the minute hand is moving. So if I look at the minute hand, 12 to 3, it takes how much time? 15 minutes. This distance. 3 to 6, how much time? 15 minutes. Only look at the minute hand. Then again 6 to 9, how much time? 15 minutes. 9 to 12, how much time? 15 minutes. And if you look at the distance traveled also, 12 to 3, 1 quarter. 3 to 6, 1 quarter. So first quarter, second quarter, equal distance. Then 6 to 9, again equal distance. 9 to 12, again equal distance. Again say equal distance in equal intervals of time. Equal distance in equal intervals of time. Yes or no? The time is 15 minutes, 15 minutes, 15 minutes, 15 minutes. The distance is also 1 quarter, 1 quarter, 1 quarter, 1 quarter. The distance is also equal. That means speed is constant. You can look at the minute hand here. It is moving at a constant speed. Yes. The same happens with an hour hand. The same happens with a second hand. The speed will be equal. That is equal distances in equal intervals of time. So this is what a uniform motion. Movement of hands of a clock is what? Uniform motion. Then what about this? A boy cycling in a crowded place. Like let's say you're cycling in a market. Then when you're cycling in a market, is your speed constant? You'll suddenly increase the speed, you'll suddenly decrease the speed. You have to apply brakes many times, yes or no, in a market, very crowded place, you have to apply brakes many times. That means your speed is increasing, decreasing, increasing, decreasing, increasing, decreasing. Your speed is not constant, that means it will be non-uniform motion. It will be non-uniform motion. Good? Okay. Then, if we look at the movement of a housefly, is its speed constant or not constant? What do you think? Movement of a housefly. It is completely random. It goes slow for some time, then increases speed, then slows, then increases, then slows. So movement of a housefly, it is not with constant speed. Its speed continuously changes. So it is again what? Non-uniform. Then a train entering into a railway station. A train entering into a railway station. What happens? When a train enters a railway station, does the driver apply brake? Yes. Does the speed decrease? Yes. So as a train enters a railway station, speed will be decreasing. And if speed will be decreasing, it means it is again a non-uniform motion because its speed is not constant. If at the beginning its speed was, let's say, 60 km per hour, the driver applies the brakes and speed decreases 60 to 50, 50 to 40, 40 to 30, 30 to 20, 20 to 10, 10 to 0. Speed is decreasing. Right? So if speed is decreasing, speed is not constant. If speed is not constant, it is non-uniform motion. Clear? Good. Then we have other examples also, same question, other examples. If you have kite in the air, it is a uniform motion or a non-uniform motion? Is it uniform or non-uniform? What do you think? So when you fly a kite in the air, suddenly you pull it, right? Suddenly you pull it, suddenly you release the thread. That means suddenly when you pull it towards you, speed will increase. When you release the thread, speed will increase. But when you hold the thread, it depends on wind. So the movement of kite in the air will also depend on wind. Wind is completely random. That means the motion of a kite in air is completely random, not constant. So non-uniform motion. Okay. Then rotation of the earth. What does rotation of the earth mean? It means this. Look at the image. Can you see earth rotating here? So earth will be continuously rotating. It's like if you take a globe, you can rotate the globe the same way. But when we rotate the globe, it depends on us. But earth will be rotating with a constant speed. Earth rotates with a constant speed. And you know how much time it takes for one rotation? 24 hours. It completes one rotation in 24 hours. So 1 day is equal to 1 rotation. Okay. 1 day is equal to what? 1 rotation. So 1 day, as we know, is 24 hours. See, there you have it. Clear? That's good. That's good. That's good. So with a constant speed, so is it uniform or non-uniform? Constant speed, it is uniform motion. And when I say uniform unit, equal distance, yes. So every 24 hours, 1 rotation. So time interval of 24 hours, 1 rotation always, you can see equal time, equal distance traveled. Equal number of rotations. So it is what? Uniform motion. Then next, the fan in an air cooler running at fixed speed. Running at fixed speed. Now it's an interesting question because here it is mentioned that the speed is fixed. Speed is constant. And if speed is constant, it is the case of what? Uniform motion. It is the case of what? Uniform motion. So in our everyday life, these are some phenomena that occur in our everyday life. And you can clearly see some of them will be uniform, some of them will be non-uniform. Okay. So just understand, uniform will mean constant speed, non-uniform will mean changing speed. Clear? Okay. So we learned about uniform motion and non-uniform motion, right? So now let's go into a few questions as practice. Okay? Okay, that's good. So look at a very simple question but a very important one. What is the SI unit of speed? The SI unit of speed is kilometer per minute, meter per minute, kilometer per hour and meter per second. What do you think is the answer? What is the SI unit of speed? Yeah, everyone, what is the answer going to be? Kilometer per minute, meter per minute, kilometer per hour, meter per second, and the correct answer is meter per second. Now why is that? What is the formula for speed? Speed, as we know, is equal to distance by time. Speed is equal to what? Distance by time. What is the unit of distance? Meter. What is the unit of time? Second. So what is the unit of speed? The SI unit of speed will be meter per second. Kilometer per hour is mostly used, I know, but the SI unit of speed is meter per second. It's a very important but basic question. Clear? Good. Next. This is a very interesting question. Ram walks to his school, which is at a distance of 3 kilometers from his home in 1 hour. Let's say this is home. Let's say this is school. So from home to school, he is going in how much time? 1 hour. And how much is the distance? 3 kilometers, but in 1 hour from home to school. On reaching he finds, on reaching where? On reaching the school, he finds that the school is closed. Now if the school is closed, what will you do? You will go back. So, and he comes back to home in 2 hours. So if he comes back, he'll come back along the same route. So if it's the same road, distance will be same. So same distance, it is again 3 kilometers, but in how much time? In 2 hours. His average speed in kilometer per hour is. His average speed in kilometer per hour is. So first of all, we have to find out total distance, total time, and then get the speed. So solve it, everyone. Solve it, please solve it. His average speed in kilometer per hour. What is that? I have explained the question. I have drawn the diagram. You just solve it. I'll give you 30 seconds of time. I'll give you 30 seconds of time. So please solve it. Find out total distance, find out total time, then you can get the average speed. Using the formula, average speed is equal to total distance by total time. Now 10 seconds more. 5, 4, 3, 2, 1. The time is up. So here, what is the total distance, everyone? See, from home to school, 3 kilometers. From school to home, again 3 kilometers. That means the total distance will be 3 plus 3, 6 kilometers. Okay. Then we have to go for total time. What will total time be equal to? The total time, first time taken is 1 hour, second time taken is 2 hours. So total time is 1 plus 2, that is 3 hours. You have total distance, we have total time. So then average speed is equal to, what is the formula? Total distance by total time. total distance by total time. Total distance we got as 6 kilometers. Total time we got as 3 hours. So 6 by 3. What is 6 by 3? What is 6 by 3, everyone? See? 3 ones are 3, 3 twos are 6. You can easily cancel out. So it is 2 kilometer per hour. That is the speed in kilometer per hour. So what is the answer? Option C. I told you, right? Very simple. If you understand the question, then it is very simple. For average speed, get the total distance, get the total time, use the formula, you will get the answer. Clear? Good. Next question. A spaceship travels 36,000 kilometers in 1 hour. Express its speed in meter per second. I'll give you 1 minute of time. Solve it. Solve it, everyone. Remember the conversion from kilometer per hour to meter per second. So we have 10 seconds more. Three, two, one. The time is up. So let me solve it for you. So what is given here? The distance is 36,000 kilometers. Time is 1 hour. There are two methods. I'll use the first method. Distance is given as 36,000 kilometers. Now here itself you can convert 36,000 kilometers into meters. I'll write 36,000 kilometers as 36,000 into 1 kilometer. What is 1 kilometer? 1 kilometer is 1000 meters. I'll just say into 1000. Leave it here. Don't do much, leave it here. Then time is given as 1 hour. Time is given as 1 hour. What is 1 hour in terms of seconds? 3600 seconds. So then if I need speed, I have to get speed, right? So if I need speed, I can take it as, the formula is what? Distance by time. So we'll take in terms of meters and seconds. In terms of meters, it is this complete 36,000 into 1000 meters upon second. Time in seconds is 3600 seconds. Now if you look at the cancellation part, 0, 0 cancel. 360 by 36. What will remain? 10. 36 into 10 is 360. So here 10 is remaining, here 1000 is remaining, 4 zeros. So it will be 10,000 meter per second. 10,000 meter per second. So the answer is what? Option A. You can say this is the first method. This is the first method. You convert directly, you can directly convert distance in terms of meters, time in terms of seconds, get speed in terms of meter per second using the formula directly. First method. Then we have second method, another method. What is that? Here we know that distance is given as 36,000 kilometers. Time is given as 1 hour. So speed is equal to distance by time. Speed is equal to distance by time. Distance is 36,000 kilometer. Time is 1 hour. 36,000 by 1 is 36,000 itself. So 36,000 kilometer per hour. Okay, 36,000 kilometer per hour. Now, what we will do is I'll convert this kilometer per hour into meter per second. How? We know that 1 kilometer per hour is equal to 5 by 18 meter per second. If I use that, speed is how much? 36,000 kilometer per hour. Now I can write this as 36,000 into 1 kilometer per hour. What is 1 kilometer per hour? It is equal to 5 by 18 meter per second. Then, if I do the calculation, 18 into 2 is 36. 18 into 2 is 36. Then what is remaining? 2 and 3 zeros. So 2000 into 5. But what is 2 into 5? 2 into 5 is 10. You already have 3 zeros. So 10,000 meter per second. You can do it anyway. This method, second method, or the first method, you will get the same answer, option A, and that is the answer. Okay, so that's good, everyone. We have other questions also, but we will practice them later on. Okay, so for today we learned about uniform motion, non-uniform motion. We practiced a few questions. The rest we'll do later on. Okay, so thank you, everyone. Thanks a lot.